Good morning everybody. Today we are going to see types of symmetry elements in group theory. First we will see how symmetry elements are defined. Symmetry elements are defined as imaginary geometrical entities such as points, lines and planes that are present in a molecule about which when symmetry operations are performed, the molecule gives a configuration which is indistinguishable from the original configuration. That is, the resulting configuration, when we compare it with the original configuration, we cannot distinguish both. And what is meant by symmetry operation? We will see. A symmetry operation is the geometrical operation such as rotation about a line, reflection about a plane, inversion about a point, etc., which when performed on the molecule gives a configuration which is indistinguishable from the original configuration. Coming to the types of symmetry elements and associated symmetry operations. There are 5 types of symmetry elements: identity, axis of symmetry, plane of symmetry, center of symmetry, improper axis of symmetry. The symmetry operation corresponding to identity is nothing but to leave the molecule unchanged, and that is denoted by the symbol E. Axis of symmetry is nothing but rotation by an angle theta, which is equal to 2 pi divided by n, or 360 divided by n about an axis, and it is denoted by the symbol Cn. Plane of symmetry is nothing but reflection in a plane, and that is denoted by the symbol sigma. Center of symmetry or inversion center is nothing but inversion of all atoms through the center, and it is denoted by the symbol I. Improper axis of symmetry, rotation about the axis followed by reflection in a plane perpendicular to the rotational axis, that is denoted by the symbol Sn. We will see identity first in detail. Identity operation is the operation of doing nothing or leaving the molecule unchanged. Every object or molecule possesses identity. The need for such an operation arises from the mathematical requirements of group theory, and it is also equivalent to 360-degree rotation. That is, after rotating through 360-degree any molecule or any object, if we see the resulting object, that is, we cannot distinguish the resulting configuration from the original configuration. That looks like nothing has been done on the molecule. That's why identity is said to be doing nothing or leaving the molecule unchanged. Next symmetry element, axis of symmetry, Cn. It is also known as proper axis of symmetry because we have one more type of symmetry element known as improper axis of symmetry. To differentiate improper axis of symmetry from axis of symmetry, we have used proper axis of symmetry. It is nothing but rotation of the molecule about an axis by an angle theta, which is equal to 360 divided by n. That gives a configuration identical to the original one, and the axis is known as n-fold axis or as C subscript n, where n is the order, that is equal to 2 pi divided by theta or 360 divided by theta. Say for example, if we take water molecule as an example, H2O, 1 oxygen, 2 hydrogen atoms are there. The hydrogen which is present in the left hand side is H1, right hand side is H2. When we rotate through 180 degree, we will get a configuration that is said to be an equivalent configuration in which H2 atom is present in the left hand side and H1 has come to the right hand side. Just 180 degree they have interchanged their place. This configuration is said to be equivalent configuration. Since by rotating through 180 degree we have got the equivalent configuration, order n is equal to 360 divided by 2 divided by 180, which is equal to 2, that is C2 axis of symmetry. Similarly, if we take ammonia as an example, when we rotate through 120 degree through a line passing through nitrogen, what will happen now? The H1 come to this place, H2 goes to this place, and H3 come to this place. We will get this configuration. This is said to be an equivalent configuration. Again, if we rotate through 120 degree through a line or axis passing through nitrogen, here again 3 will come here, 1 will go there, and 2 will come here. We will get the equivalent configuration. Again, if we rotate through 120 degree, that is C3 3 times, nothing but 120 plus 120 plus 120, 360 degree. We will get a configuration which is identical to the original one. That's why C33 is said to be E. Since by rotating through 120 degree we are getting equivalent configurations, N is equal to 360 divided by 120, which is equal to 3, threefold axis of rotation, that is C3. Water and ammonia are non-planar molecules, that is all the atoms, they do not lie in the same plane. If we consider a planar molecule like BF3, 3 fluorine atoms and boron, all of them lie in the same plane. Here we are choosing an axis which is passing through only boron, and if we rotate through 120 degrees, say for example like this way, if we consider BF3 like this way, we are considering an axis which is passing through this boron only. Okay, that is the Z axis, and the molecular plane is XY plane. In that case, if we rotate through 120 degree, F1 will come here, 2 will go there, the equivalent configuration we will get. Similar to ammonia, again 120 degree if we rotate, we will get a equivalent configuration. Again if we rotate 120 degree, we will get the original configuration. Along with the C3, we will have a 3C2 axis of rotation for BF3 molecule. That is, if we choose an axis passing through boron and F1 bond by 180 degree, these two will interchange their position, we will get equivalent configuration. Similarly, if we choose a line passing through boron and F2 through 180 degree, these two will interchange, we will get the equivalent configuration. Similarly, if we choose a line passing through boron and F3, again 120 degree if we rotate, these two will interchange, we will get a equivalent configuration. That is, as we conclude, in addition to C3 axis in BF3 passing through nitrogen, this type of planar molecule possesses 3 more twofold C2 axis which are perpendicular to the C3 axis passing through boron and one of the fluorine atom. These are in the plane of the molecule. If the rotation about an axis yields equivalent configurations in infinite number of times in 360 degree rotation, then the symmetry axis is represented as C infinity. All linear molecules possess this C infinity axis of symmetry. If a molecule possesses more than one Cn axis of different order, then the axis of highest order is considered to be the principal axis. If several rotational axes of same order, same n value exists, then the one passing through maximum number of atoms is considered to be the principal axis. And in general, Cn is equal to identity. That is C22 identity, C33 is equal to identity, C44 is equal to identity, that is 360 degree rotation. Thank you.